back to transformations, that 6 inside is going to be a horizontal, because it's inside, and it's going to be a compression, because you would multiply x by 1/6. Now, our shortcut for graphing with a number inside. Normally, I had 2 pi and had my axis span. But now, instead of having a period of 2 pi, I've compressed it by 1/6. Does it make sense that multiply 2 pi by 1/6 would give me 2 pi over 6? I could reduce that to pi over 3, but I'll leave it as 2 pi over 6 so that we can really see that all I did was take 2 pi and divide it by 6. Then, cut this into 4 equal sections. You don't even have to do the math on those sections with dividing by 6, because, does it make sense? I always do this one first. If this is 2 pi over 6, this would be half of that. What's half of 2 pi over 6? Close. 1 pi over 6. Because if you were doing 1/2 times 2 pi over 6, the 2's would cancel out, and you have 1 pi over 6. But then half of pi over 6, I would do this purple dot next. What's half of pi over 6? Pi over 12. And then I would do this orange dot last by using the purple dot. I know this is 1 pi over 12. Since these are all equally spaced, does it make sense that this is 1 pi over 12, 2 pi over 12, 3 pi over 12s? Because they're all equally spaced. Again, I could reduce that to pi over 4, but I think this helps us understand it better. What's the amplitude of this one? It's still 1. Nothing's affected the y. So we can go on our y-axis and put 1 and -1. And then we have to think about our parent graph. Where does a cosgraph start? You'll hear me saying this often. A cosgraph, y equals cos x, always starts at a maximum. So a cosgraph starts at a maximum. That means on my graph here, I'm going to start here. And once you have 1 point for sine and cos graphs, maximum, then center line, then minimum, then center line, then maximum. And the period is this length from here to here is how long it takes to repeat itself. Would be 2 pi over 6 or pi over 3. Because the period was normally 2 pi, and we've had a compression by 1/6. So now we have a period of 2 pi over 6. Right, part B. Tan equals 2/3 x. This one, horizontal stretch, you will multiply your x values by 3/2. If we think about our tan graphs had asymptotes. It had an asymptote here that was at pi over 2. It had an asymptote here at negative pi over 2. And I mean, it kept on going. We could, I don't know, scale I'm not even, it's too far off. Okay? Now, if this asymptote was at pi over 2, and we multiplied our x values by 3 over 2, 3 over 2 times pi over 2 will be 3 pi over 4. And this one then would be at negative 3 pi over 4. That point won't change. I guess that's all I can show before it runs off, but it repeats itself. The period is from here to here, how long it takes to repeat itself. 6 pi, the distance would be, add these two together?
Yes.
6 pi over 4, or 3 pi over 2. And if you think that the period of 10 normally was pi, we are multiplying by 3 over 2, our new period is 3 pi over 2. And finally, the last graph. Is that too fast? Is y equals sine x over 7. Are you okay to write the x over 7 as 1/7x? And then recognize this is a horizontal stretch, where you would multiply x by 7. Normally when we graph sine, we make a mark and make 2 pi. But if I multiply my x values by 7, 2 pi times 7 would give me 14 pi. Divide this into 4 equal sections. Do the middle one first. What's half of 14? What's half of 7? 3.5. Or you could just leave it as a fraction. 7 over 2. And then if you wanted to do the third one, 1 7 over 2, 2 7 over 2s, 3 7 over 2s, would be 21 pi over 2. Amplitude is still 1. The y values haven't changed. And where does a sine graph start? A sine graph starts in the middle, going up. So you just go from section to section. And this is way faster than the arrows, because you would have had 5 points to do with the arrows, and it would take a lot of space. So our shortcuts here are making things quicker. First shortcut we learned was the amplitude. Second shortcut we learned is that any horizontal stretch or compression will change the period. In this one, right, how long does it take to repeat itself? Period is 14 pi. So circle the questions C and D in part 3, and then at the bottom of the page, I want you to write these formulas down at the bottom of page 517. This formula is not on your formula sheet. But whenever you have a horizontal stretch or compression, there's a formula for figuring out the period. And if you know the period, there's a formula for figuring out what the B value is. And it's pretty straightforward, because if you had a B value, like a 3, is a horizontal compression by 1/3. You would take 2 pi and divide it by 3 to get the new period. So this is just showing horizontal stretches and compressions into a formula. And for tan, since the period of tan starts off as pi, the formulas are the same, just with pi instead of 2 pi.